My favorite question to ask in an interview. This one is super common. You really need to know how to approach this problem. In fact, it's one of my favorite problems to ask, and I've asked it in pretty much every single interview I've ever given. And I've been asked it myself, and I've also failed it miserably, and now I have a pretty good method of working through it. So, this is an interesting problem. And the reason why I like to ask this one is because there's so many different approaches you can take to it. Well, there's at least three that I can think of off the top of my head, and we'll just go through a couple of them. In my opinion, the correct or more efficient version, and two, the brute force version of this one. And people will either go with the brute force, or sometimes they'll have no solution, which can be a deal breaker in an interview. But I think as long as you have like a way to approach this, it's good. So let's dive into actually the constraints of this problem and how we're going to go about solving it. So, have an array of integers and a number target we want to hit. We want to see if there are two elements in this array that will sum to the target, and we return the indices of those numbers. So for example, here we have 2 and 7, and what I like to do when I'm doing these problems is I typically like to put it over here, right? This helps me draw some thoughts out about what's going on. So I have num target, and I have the output is 0 and 1. Why is the output 0 and 1? Because 2 plus 7 equals 9. Okay, seems reasonable. If I was in a real interview, I'd go through this in some more detail and say, okay, what if I had 2 and 2 here, and the answer was 4? You couldn't return 0, 0, because 2 and 2 is 4, obviously, but 2 is an index 0, and you wouldn't want to add it to itself, so it'd have to be 0 and 1. So that's a little tricky thing we need to probably watch for to make sure we're not actually giving the same number, in this case, using the same number twice. It even tells us here in the problem constraint. So I think we have a pretty decent idea of how to approach this problem. We return the indices of the numbers that sum to the target. And it says there's going to be exactly one solution. And okay, and we can return the answer in any order. Seems pretty straightforward. So how would you solve this problem? I can think of one pretty naive way to do it, which is to loop over every single number 2 times, right? We could look at 2, and we'd say, okay, now let's look at every other number besides 2 and see, do any of the numbers not including 2 sum to target 9? So we look at 7, 11, 15. We say, oh, yeah, they do. Then we'd look at 7. We'd look at all the numbers after 7. Say, does any number after 7 sum to 9? So if we have to look at 11, 15. No, they do not. Then we'd look at 11 and 15. No, we don't. So the way you could write something like that out would be like this. For let I equals 0 such that I is less than nums dot length I plus plus. And then we could do another loop, right? For let j equal I plus 1 such that I is less than nums dot length a plus plus. So now we need to check if they actually equal the target. So we look at if nums I plus nums j equals our target. Well, then what do? We would need to return the indices. Remember, not the numbers, but the indices. Return I, j. Let's just run this and see if this actually gets us to what we want. Okay, so this is actually accepted. Now, is this a terrible solution? No, it works, right? For this particular example right here, right? This actually works. It's a nested for loop. So when you hear nested, you should think, what's my runtime here? What is the runtime complexity here? And if you're not familiar with big O notation, definitely check it out. It's basically how much is the runtime affected by the length of the input. So as the input grows, how much does the complexity or the runtime get affected by the growth of the input? And in this case, well, if the input was really, really long, we'd be going over every number at a worst case scenario 2 times. So this would be an n squared solution. N squared solution currently. Now, Not great, right? You say, well, for a pretty small amount of numbers, it's not so big of a deal. But when you hear n squared, and then the interviewer like you say, well, how can we speed this up? You're thinking, whenever an interviewer says, how can you speed up a problem? Immediately, I want you to think hash map. That is the most common way to speed up your algorithm. So think hash map. Now, how could we use a hash map in this case? Even if you don't exactly know how to, as a little hint, I would just say, maybe we could use a hash map. Maybe the interviewer actually pointing in the right direction and point says, that's a great idea. I'm glad you suggested that. How could we use a hash map? But let's think about this. Okay, let's go back down here. Our target is 9, right? So we know when we look at any number in this array, we know that if we're on a certain number, we have only one other number will actually sum to it. I'll give you an example. So we're at 9. Let's say the first number out is 2. What is 9 minus 2? It's 7. Is there a 7 in here? True, there is a 7. Okay. If we're at the number 7, right? So we have 9 the target minus 7. That equals 2, obviously. Is there a 2 in here? Yeah, there is. Now let's do 9 minus 11. Or, yeah, it'd be 9. Yeah, 9 minus 11, which is the third item in this array. And that's negative 2. There is no negative 2 in here. But you see what's happening here. At every iteration, we know exactly what number we must have to find. For example, if we're at the number 2, we know that we have to find a 7 because no other numbers will sum to 9. If we have a 2, then we know we have to find a 7. If there is a 7 in the array, we want to return the index of that number. And I'm going to use a hash map. Now, how can we speed this up and make it really easy to find a number and match it with index? Well, we could make a little hash map that maps all numbers to their index. Then we could look at the number we're currently on, see if the missing number, for example, in the case of 2, we'd say, oh, is there a 7 in this hash map? Oh, there is. What is the index of it? Bam, we have the answer. How does that look like in practice? Let's do this. Const. We'll just call this math equals, and we'll actually reduce. So nums dot reduce. We'll take an accumulator and a current, and here's what we do. And we'll take the index. So we're not going to go over how to use reduce here, but definitely something you can look up yourself, something you probably want to be familiar with, especially in the context of an interview. So the accumulator in this case will be this object, and we'll take the current number and we'll make it equal to the index. Return ACK. Return the accumulator. We always must return in a reduce. So now we have our map. Now we do a very simple loop for let I equals 0, such that I is less than nums.length I plus plus. Now we go to what's it called? What's called missing target maybe, and we're going to do target minus nums at index I. So for example, the first time this runs will be at 2. And we'll say, okay, well, 9 minus 2 is 7. We know we have to find 7. And now we just look in our map and see if it's in the map. If map contains the missing target, well, we know we got it, right? We're going to return I and map missing target, which will give us the value of that of the missing target. In this case, it'll give us the missing target would be 7, and 7 is at index 1. So this would give us 0 and 1. Now, let's see if this works. This actually works as well, right? Now, let's actually console log this map, because this may be easier to understand exactly why this map is really important and usable here. So look at this map. We have the number 2 at index 0, we have the number 7 at index 1, we have the number 11 at index 2, and I have the number 15 at index 3. Makes sense, right? So, for example, when we are iterating over this, let's just put this here. when we are iterating over um, this set of numbers, we look at the missing targets. In this case, we'd have 9 minus 2. So the missing target is 7, right? This is the missing target. If the map has the missing target, does it have the missing target? Yes, it has 7. Then we return I and map at the key missing target. This key 7, the value of that is 1. So now we return 0 and 1. And this is a way to speed this up. Now we have constant lookup time. We remove an additional for loop, and we have a much more performant answer. So I hope you learn through this that, first of all, sometimes just writing out, doing a little drawing, sketching, and it's always good if you can't come up with a great answer at first. You say, okay, you come up with a brute force answer. You come up with something. And then if you come up with that fast enough, you'll have time to optimize it. When you optimize it and your interviewer hopefully gives you a nice little hint saying, how can we speed this up? You can say, what if we used hash map? They say, yeah, that's probably a great idea. How could you use that? Ideally, that can start a conversation if you're not super sure of how to attack it, and you can hopefully build up something like this. Now, this is a common kind of pattern right here. Using reduce, you could use a for loop. Definitely suggest you look this up and check out this problem. It's labeled easy. I would say that there's many ways to get this. You could have 2 pointers as well. I like this solution a lot. It's pretty succinct. To me, it makes sense in my head. You might have your own mental model and what makes sense to you. So hopefully this was helpful.